Oh my gosh! If I gain negative, what am I am negative. I do need. So these ones, this first column, we said that they wanted to go from 11. If we lose one, it would go to 10. And this is the column we want, the noble gap. 19 wants to do what? Lose one to go from 19 to 18. So all of these in the first column want to lose one electron. Lose negativity. What are you, George? Lose negative. You are? With what number? We just said they want to lose 1. So up of this first column. Every element in that column, every time, is going to have a +1 charge. What do you think the second column is going to do? They would minus 2 electrons, but what would we call their symbol at the top? All right, we are going to skip this middle section. Let's call this middle section. We're going to skip this for now, and we're going to move to column A. Let's do this. So some of the people had 3 items. Okay, so we've got either one begins with 0 or 8 in our activity. We've got 0 or 8, we're a winner. Or is right in the middle. So this is the green one. Do you want to go left or right? Go left. I once said if you did this, you would have to run around the school, make the school so that you jumping jacks. How many jumping jacks do I do? Only 3 or 5? So we're going to go this direction. And so that one will be, again, positive. So we're seeing a trend. +1, +2, +3. Now at 4. I heard somebody say +4, but I also heard somebody say didn't you know this correct? Yep. Call this one +4 -4. All right, and then the last one, let's see if we can figure out the pattern. I'm now at 5. Fifth column. Which direction is better going? 5 left?
3 right.
3 right.
3 right.
3 right. But what am I doing? I'm not losing them anymore. I am gaining negativity. So these ones
-3.
negative charge. And here's our pattern. It's like a ramp. +1, +2, +3, ±4, -3, -2, -1. And then the last one is 0. Yes, Kate?
So how do you even know that it works to lose your gain?
Just the simple fact of how much energy it takes to get there. So 3, if you had to run 3 miles to go back to 0 versus 1, 2, 3, 4, 5, I'm going to choose a 3. Right? If I do as least energy as I want to give up. So if I have the option here, Casey, of going from 1 to either 0 or 8, what's the easiest way to go? Go to 0. One trick. We do it to save energy. Okay, we go the simplest way. If I can go left to get there, I don't want to go what? Energy. Think about using the least amount of energy. You should be writing those down. On your periodic table, yeah? I did say take your periodic table out. So you should have your periodic table. You don't have to necessarily write this ramp, but it might be helpful. So when I talk about that first part up at the top of the sheet I just gave you, what do you need to know? You need to know +1, +2, +3, +4, -4, -3, -2, -1, and 0. That's what you need to sort of know. right, so let me ask you an element. What would the charge of aluminum be? Look at your periodic table. Aluminum, Al, what would its charge be? Al is in the +3 column, so you'd write Al +3, and you've just done well on your quiz. By the way, we're going to have a quiz every day 3 from now on till the end of this semester. What? Because this is a lot to think about, and I want you to keep trying it.
Are we doing that tomorrow?
No. Tomorrow's not busy.
Oh,
Every day. Okay. Yes.
So how many questions were there?
It's like a single-sided sheet, 10 points, 20 points each time.
Oh, that's not bad.
So it's not. All right. What I do want you to notice is that these first ones, the positive ones, always keep their name. Hydrogen stays as hydrogen. Lithium, sodium, potassium, rubidium, cesium all keep their name. But what do you notice with all of the negative ones? They lose not the whole name. They lose some of the name at the end, so fluorine becomes fluoride. Chlorine becomes iodide. Take off the ending, add ID. All right. There are a couple transition metals that you need to know that have specific charges. If you look down in the next section, most transition elements have multiple options. But there are 3 that only have one option. So when I say that we have these quizzes and we have to memorize them, if I asked you what silver is, you would need to write down Ag + 1. But you get a periodic table, so you would know that silver is Ag. It says it on the name. You just need to know that it's a +1. Zinc, you need to study a little bit and know that zinc is +2. And cadmium is also +2. Here's a little hint for those ones. Here's a little hint for those ones. Exactly. So, Josiah just caught it. Notice this says 1B here. What is the charge of silver, do we just say? +1. We just talked about 2B. What are the charges of both zinc and cadmium? +2. That does not apply to copper, though. It does not apply to gold or mercury. These 3 are a little bit different. Are we understanding the saying? Yes. We have to understand and memorize some of these ions. And I'm bringing this up. We'll have a lot of practice today in the next couple days to understand how to do this. But I'm just letting you know some things you have to memorize. Silver, cadmium, and zinc. 1 means +1 for silver. 2 means +2 for cadmium and zinc. All right. All right, do you know your Roman numerals? Some of you said yes, some of you said
because it's Star Wars.
no. All right, how do we do this? Let's see. If you don't remember your Roman numerals, let's take a look. 1 is represented by a single I. Well, if I have 2, then I'm going to put 2 I's next to each other. If I have 3, I'm going to put 3 I's next to each other. The next thing you need to know is what 5 is. 5 is the letter B. B. Quiet, please. What is 1 before 5?
4.
4. 1 before 5 is 4. What is 1 after 5?
6.
1 after 5 is 6. 2 after 5 is 7. 3 after 5 is 8. Now we switch to what 10 is. You need to know what 10 is. 10 is X. 1 before 10 is 9. So really what you need to know is that 1 is represented by a single I, V represents the number 5, and X represents the number 10. Then just figure out how much before or after.